Good morning, children. Having studied matrices and determinants, types of it, properties of it, operations on matrices, today we are going to do some applications in matrices in various fields. Matrix, by name itself, somewhat beautiful, isn't it? Almost all the beautiful arrangements in nature are matrices, that is, in rows and columns. Yes, we have matrix arrangement in seating, in celling, in grid forming, flower arrangement, and most appropriately in architecture. The various constructions, we have rows and columns arrangement. Matrix operations plus, minus, into. These are very much useful in organization. Where we are recording data in rows and columns, we use matrices. Multiplication of matrices, a wide application in almost all the fields. Wherever we multiply quantity and price to get cost, or we have even matrix multiplication applied in gene expressions, in counting the level of RBCs in a person, and in all simple algorithms. Transition matrix, which we will study next year, is an important tool in business evaluation. Matrices, the transformation, is commonly used in computer graphics and image processing. Is division possible in matrix? No. Instead, we have the inverse operation. Inverse operation is a gift to solve equations of any number of variables. Solving equations is almost applied in all fields of engineering, especially in science solving AC network equations of electrical circuit. Matrices are used in computer animations as transforms, in scaling, translation, reflection, rotation. In all these cases, we use matrices. Also, the graphing helps us to take seismic surveys in geology. And most appropriate use we say in robotics, where the orientation and positioning is important, we are using matrices. And moreover, we have a special field called cryptography, wherein the coding is used. Coding and decoding secret messages are done using matrices. Now the question is, are we doing any of these applications this year in our chapter? Yes, of course. The most important application of matrices in economics is input-output analysis. In today's class, we are going to learn about input-output analysis. What is this input-output analysis? Let us consider two industries in the market. For example, let me say manufacturers of cycle. Does cycle just jump out from a machine? No. Many parts of it have to be fixed in to produce a cycle. So the frame of the cycle, the tire, tubes, bulbs, bells, all these things are there. So let me say industry A is producing the frame, whereas industry B is producing tire, tubes, bulbs and bells. All the fittings the industry B is producing. Now both are manufacturers of cycle only. So A is giving frame to B, whereas B is giving tires, tubes, bulbs and bells to A. So now the question is, A has to produce for its own and A has to produce for B also. Similarly, B has to produce whatever A is using and B has to produce for B also. So, industry A produces for its own needs as well as for B. Industry B produces for its own needs as well as for A. So, in practical life, there are many industries, but since we are beginners, we are using only two industries interdepending on each other. This matrix we call the initial matrix, from which we deduce the technology matrix. What is the technology matrix? Here, I must also tell you what is the demand for the industries and the outputs also. So, the outputs we call X1 and X2. The demands, let me call D1, D2. When I say B, I call it as technology matrix. And how to find this technology matrix? We call it as B11, B12, B21, B22. What is this B11? B11, I call it as A11 by X1. Similarly, B12 is A12 by X2. What is B21 then? A21 by X1. What is B22? A22 by X2. See how to remember. This ending number will come down. A11, I put X1 down. A12, I put X2 down. A21, I put X1 down. A22, I put X2. First row, first column, first row, second column. Second row, first column and second row, second column. So as I find out this B, find out I minus B. What is I? I we call the unit matrix of order 2. 1, 0, 0, 1. After finding I minus B, find out the inverse of it. Multiply with the demand matrix. The demand matrix we write in column D1, D2. As I multiply, I get what should be the gross production. So this exercise, this is our main idea, finding out the technology matrix, finding out I minus B, the whole inverse, multiply with D. So these are important under 5 marks. Now, the system, is it possible to do it? The analysis, is it possible? So Hawkins and Simon, they have given a condition to check whether the system is viable. So we say the system is viable if the system follows the two conditions laid by Hawkins and Simon. What are the two conditions? As I find out this I minus B, the diagonal elements must be positive. So in I minus B, diagonal elements must be positive. So first condition, diagonal, I have to check like this in I minus B. So diagonal elements must be positive and determinant I minus B must be positive. So two things we say laid by Hawkins and Simon for the system to be viable. Condition number 1, the diagonal elements of I minus B must be positive, and condition 2, determinant I minus B must be positive. If these two conditions are satisfied, proceed on to find out I minus B the whole inverse into D so that I can find the gross production. Now let us continue with the exercise problems. Exercise 1.4, question number 1. Test whether the system is viable as per Hawkins and Simon conditions, given the technology matrix. So the given question is technology matrix, so call it as B. 0.50, 0.30, 0.41, 0.33. Find out I minus B. We should know what is I, that is 1001. Find out I minus B, that is 1001 minus 0.50, 0.30, 0.41, 0.33. How do you subtract 1 minus 0.50? As we subtract corresponding elements, 1 minus 0.50 is 0.50. 0 minus 0 minus 0.30 minus 0.41 and 1 minus 0.33 is 0.67. The main diagonal elements are positive. Second, I need to find out determinant I minus B. Determinant tells me multiply 0.50 into 0.67 minus 0.30 into minus 0.41. As we multiply 0.5 into 0.67, minus into minus is minus 0.30 into 0.41. As we subtract, we see the answer is positive. So main diagonal elements in I minus B are positive. Determinant I minus B is positive. Therefore, the system is viable as per Hawkins and Simon conditions. Question number 3. Given the technology matrix, we are going to proceed in the same way. We need to find out I minus B. So 1001 minus 0.50, 0.25, 0.40, 0.67. Subtract the corresponding elements. 1 minus 0.50, 0 minus 0.25. 0 minus 0.40, 1 minus 0.67. So we find out the answer and the main diagonal elements are positive. Therefore, proceed on to the second condition. The second condition is finding the determinant. 0.50 into 0.33 minus 0.40 into 0.25. You can use the calculator, multiply these two, and as I subtract, my answer is positive. So we declare main diagonal elements in I minus B are positive. Also, determinant I minus B is positive. Therefore, the system is viable as per Hawkins and Simon conditions. Question number 2. 0.6, 0.9, 0.2, 0.8. So we need to find I minus B. So let us substitute. I is 1001. As I subtract 1 minus 0.6, my answer is 0.4. 0 minus 0.9 minus 0.9. 0 minus 0.2 minus 0.2. 1 minus 0.8, it is 0.2. Now, the main diagonal elements are positive. Therefore, I can directly go on to the determinant value. 0.4 into 0.2 minus 0.9 into minus 0.2. It is 0.08 minus into minus is minus 0.18. My answer is minus 0.10, which is negative. So we will say determinant I minus B is negative, and hence the system is not viable. So very important, the system is not viable. So sometimes the system may not be viable also. So Hawkins and Simon conditions help us to check whether it is viable or not. So even if main diagonal is positive, determinant is negative, we will immediately say the system is not viable. So these problems will come under 2 marks. Remember the two conditions. Main diagonal of I minus B must be positive. Determinant is positive, it is viable, and negative tells it is not viable. Exercise 1.4, question number 7. Given production sector XY, consumption sector also XY. Domestic demand, gross output are given. We need to find when the demand changes to 12 and 18. Find the gross production. As I read XY, let me write. This is 15, 10, 20, 30. And the demand, we read from the last line, that is 12 and 18. 12 for X and 18 for Y. The output that is already given is 35 and 65. Take this as X1 and this as X2. This matrix we call demand. And as I see this 2 by 2 rows and columns, treat them as A11 15, A12 10, A21 20, A22 30. Now we need to find out B matrix. What is B matrix? It is nothing but B11, B12, B21, B22. How to find out this B11? It is A11 by X1. A11 is 15, X1 is 35. You can cancel 5 table 3 by 7. B12 is A12. The same order I will write. By 2 it ends X2. What is my answer? A12 is 10 divided by X2 is 65. As I cancel by 5 table, 2 by 13. B21 is A21 by X1, that is 20 by 35. 4 5s are 7 5s are. B22 is A22 by X2, that is 30 by 65. Cancel by 5 table, 6 times by 13 times. Now we will write the matrix B and we call this as the technology matrix. So what is the technology matrix? B11, that is 3 by 7, 2 by 13, 4 by 7, 6 by 13. We find out I minus B, the next step. What is I actually? 1001 minus 3 by 7, 2 by 13, 4 by 7, 6 by 13. As we subtract, let us write down 1 minus 3 by 7 corresponding elements. 0 minus 2 by 13, 0 minus 4 by 7, 1 minus 6 by 13. And my answer is 7 minus 3, 4 by 7, minus 2 by 13, minus 4 by 7, 13 minus 6, that is 7 by 13. Once I find out the main diagonal is positive. So let us write down the main diagonal elements are positive. So the first condition is satisfied. The main diagonal elements are positive. Proceeding to the determinant. Now we see determinant I minus B is multiply the diagonal elements 4 by 7 into 7 by 13 minus 2 by 13 into minus 4 by 7. 28 by 91 minus into minus minus 8 by 91, that is 20 by 91. Next, find out adjoint of I minus b. This is also positive. So the system is viable. I can proceed. What is adjoint? Looking at I minus b, we have to interchange the main diagonal. So my answer 7 by 13, 4 by 7. The other diagonal, change the symbol. Plus 2 by 13 plus 4 by 7. Once I have written the adjoint, the inverse, we know the formula. A inverse is 1 by determinant A adjoint of A. Using that formula, what is I minus b? The whole inverse 1 by determinant I minus b. My answer is 20 by 91 into adjoint 7 by 13, 2 by 13, 4 by 7, 4 by 7. I need to multiply this with D to get X. So 20 by 91 reciprocate 91 by 20 into 7 by 13, 2 by 13, 4 by 7 into the demand matrix which we had written originally 12, 18. This is from the last line of the question 12, 18. Keep 91 by 20 as it is. Let us multiply. First row by first column. 7 into 12. 84 by 13 plus 2 by 13 into 18. 2 into 18. 36 by 13. Second row by first column. Write it in second row. 4 into 12. 48 by 7 plus 4 into 18. 72 by 7. This gives me 91 by 20 into 84 plus 36, 120 by 13. 48 plus 72, again 120 by 7. Now take this 91 by 20 inside. Multiply. 91 by 20 into 120 by 13. Second number 91 by 20 into 120 by 7. As we multiply and cancel, it is 42 and here it is 78. So take and write the answer. Industry X should produce 42 units and industry Y should produce 78 units. Exercise 1.4, question number 4. Two commodities A and B are produced such that 0.4 tons of A and 0.7 tons of B are required to produce a ton of A. See, as I read it, 0.4 tons of A and 0.7 tons of B. So there is no output given here. So 0.4 A under A, 0.7 A under B I will write. The next line. Similarly, 0.1 ton of A and 0.7 ton of B are needed to produce a ton of B. So for B, we say 0.1 ton of A and 0.7 ton of B. And this we call technology matrix capital B. Now, to proceed with the problem, we need to know what is I. I is 1001, the unit matrix of 2 rows and 2 columns. Now what is asked in the question? Write down the technology matrix. The technology matrix is B11, B12, B21, B22, which we have written here. The next step. If 68 tons of A and 10.2 tons of B. So this I call demand. The demand matrix D equals to, what is given for A? It is 68 And what is given for B? It is 10.2. A, B. So as we write, this we call demand matrix. The question is to find the gross production of both of them. So as I know I and B, my next step is to find I minus B. 1001 minus 0.4, 0.1, 0.7, 0.7. Subtract 1 minus 0.4, 0 minus 0.1, 0 minus 0.7, 1 minus 0.7. So these two I just change the symbol because it is 0. These two I subtract from 1. As I get I minus B, I have to check the determinant of it. What is determinant of I minus B? Multiply 0.6 into 0.3 minus 0.1 into minus 0.7. Determinant I minus B equal to 0.18 minus into minus into minus minus 0.07, which is 0.11, and it is positive. Now we know what is B and what is determinant I minus B. Main diagonal elements in I minus B is positive. Determinant I minus B is positive. So the system is viable and we can proceed. Proceeding to adjoint of I minus B. How to write the adjoint? Interchange the main diagonal, that is 0.3, 0.6. The other diagonal, change the symbol 0.1, 0.7. The next step, find out I minus B the whole inverse. I minus B the whole inverse equals to 1 by determinant of I minus B into adjoint of I minus B. 1 by determinant is 0.11, the adjoint is 0.3, 0.1, 0.7, 0.6. The next step, we want the gross production X, which is nothing but I minus B inverse into D. X is equal to 1 by 0.11 into 0.3, 0.1, 0.7, 0.6 into the demand. Change it in the question. It is not 68, it is 6.8. So 6.8 into, and the second number is 10.2. As I multiply, you can use your calculator. First row by first column. Multiply and write the answer. 0.3 into 6.8, 0.1 into 10.2. 0.3 into 6.8, 0.1 into 10.2, 0.7 into 6.8, 0.6 into 10.2. Add them. As we add, divide by 0.11. So as we use the calculator, we get 27.82 and 98.91. Take and write the answer. Gross production of X is 27.82 tons and gross production of Y is 98.91 tons. Exercise 1.4, question number 5. Production sector, consumption sector, domestic demand and total output are given. From the question, what all I understand? What is A11? 30. A12 40. A21 20. A22 10. Demand 1, demand 2. We read from the last line, not this one. Remember, from the question, this is initially. What is actually given if the demand changes from the given things to 80 and 40. So the last line tells me demand 1, demand 2, 80 and 40 for X and Y. Total output. That tells me X1 and X2. X1 is 120 and X2 is 60. We need to find out the technology matrix. What is the formula for the technology matrix? B equals B11, B12, B21, B22. And we should also know what is I, that is 1001. Finding out B11, A11 by X1, B12 is A12 by X2. B21 is A21 by X1 and B22 is A22 by X2. As we substitute 30 by 120, 40 by 16. Which is 2 by 3. 20 by 120, that is 1 by 6. 10 by 60, that is 1 by 6. We take and write the B matrix. 1 by 4, 2 by 3, 1 by 6, 1 by 6. Proceed on to I minus B. As we subtract 1 minus 1 by 4, 3 by 4, 0 minus 2 by 3, minus 2 by 3, 0 minus 1 by 6, minus 1 by 6, 1 minus 1 by 6, 6 minus 1, that is 5 by 6. Main diagonal elements are positive. Proceed on to find determinant. 3 by 4 into 5 by 6 minus 2 by 3 into minus 1 by 6. 15 by 24 minus 2 by 18. We can still cancel. It is 5 by 8 minus 1 by 9. Taking the LCM 72, cross multiply 45 minus 8. So as we simplify, we get a positive number. So say the system is viable by Hawkins and Simon conditions. Now we need to find out the inverse of I minus B. The very first step, adjoint of I minus B. How to write the adjoint? For I minus B, interchange 5 by 6, 3 by 4. Change the symbol 2 by 3, 1 by 6. The next step, I minus B, the whole inverse. 1 by determinant I minus B into adjoint of I minus B. That is, I minus B, the whole inverse is equal to 1 by 37 by 72 into 5 by 6, 2 by 3, 1 by 6, 3 by 4. X is equal to I minus B, the whole inverse into D. I minus B, the whole inverse is 72 by 37 into 5 by 6, 2 by 3, 1 by 6, 3 by 4 into the demand from here, the last line of the question, 80, 40. Now see, these numbers are difficult to multiply. You can also use the calculator and turn it into decimals. 72 by 37, you can use your calculator and simplify. 5 by 6, 2 by 3, 1 by 6, 3 by 4. Those who are comfortable with fractions, multiply using fractions. If not, use your calculator, divide and get decimals like this. How to multiply? First row by first column. 0.833 into 80 plus 0.667 into 40. Second row, 0.1667 into 80 plus 0.75 into 40. Multiply and then add it. As we add the two, we get 93.32 first row, second row 43.336. Multiply with 1.946. 1.946 into 93.32 is 181.6. 1.946 into 43.336 is 84.33. So the first industry output is 181.6 and the second industry output is 84.33, and that is the answer. Take and write the answer, output of X and output of Y. Whatever answer we get, that many units.